In Chapter 4.1, we're going to be looking at how to evaluate expressions that have exponents in them. Now, I know you've seen these before, but let's just review some of the vocabulary. If I'm talking about the fifth power of 3, that means I'm using the base of 3, the exponent is 5. The base, remember, tells us how many times, the base tells us what number to use as a factor. So in this case the base is 3. We're going to use it as a factor, multiply it by itself. And the exponent tells us how many times to use the base as a factor. In this case, 3 to the fifth power means we're taking the base of 3 and multiplying it by itself, using it as a factor 5 times. Now when we write a power with a base and an exponent, that's called using the exponential form. And when we write a series of multiplications, or when we write showing the factor being multiplied by itself, that's called the expanded form. You're going to want to be familiar with that vocabulary. You're going to see it in directions on tests and quizzes and all over the place. So make sure you understand what you're being asked if someone asks for the expanded form or if someone asks for the exponential form. Alright, so let's look at these first couple examples. We want to write each expression using an exponent, and we want to state the power. In example 1, we're using the base of 5 as a factor 4 times. We're multiplying 5 together 4 times. So that means our exponent is 4. And we say that this is the fourth power of 5. In example 2, the base is negative 7. We're multiplying it by itself 3 times. That means our exponent is 3. And we would say the third power of negative 7. All right, let's practice evaluating some expressions here that have exponents in them. So example number 3 says we're going to take the base of negative 2 and raise it to the third power. Use the base of negative 2 as a factor 3 different times. So negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. In our next example, we have 10 to the fourth power, which means use the base of 10 as a factor 4 times. 10 times 10 is 100, and notice I'm just following order of operations here. That's what we do when we evaluate. 100 times 10 is 1,000, and then 1,000 times 10 is 10,000. So 10 to the fourth is 10,000. Something interesting to note here. Notice how many zeros are in the answer when we took 10 to the fourth. Keep that information in the back of your mind for some time later. Example 5, negative 5 to the fourth power. So we're going to take negative 5 as a base, use it as a factor 4 different times. Let me fix that. That doesn't look very nice. Okay, so negative 5 times negative 5. Positive 25. Positive 25 times negative 5 is a negative 125. And negative 125 times negative 5 is positive 625. Okay, now how many of you paid attention up here to the note that says always use parentheses when the base is a negative number? Okay, that really is important. Notice in examples 3 and 5, the base is in parentheses. If there are no parentheses, it really does mean something different, and sometimes it will make a difference. So let's look at those two examples again without parentheses around the base. If we have negative 2 to the third power with no parentheses, that means we're taking the base of 2 and cubing it, taking it to the third power. And then you apply the negative to that. So that means we're going to take the negative of 2 times 2 times 2, we're taking the negative of 8, which is negative 8. We got the same answer as we did the first time. But now let's look at example 5. Negative 5 to the 4th. If we write that without parentheses, that means we're going to take the base of 5, take that to the 4th power, and then apply the negative, which means we're going to take negative of 5 times 5 times 5 times 5. We're going to take the negative of 625. We get negative 625. Notice in this case, the sign was the opposite of what it was the first time. So if the exponent is odd, it's really not going to make a difference if you put those parentheses around your base. But if the exponent is even, like in example 5, it does make a difference. So you always want to use parentheses if your base is a negative number, because sometimes it is going to actually change the value of your answer. All right, here's some more practice problems. Notice the directions. Complete to simplify each expression. We can use the words evaluate the expression. We can use the words simplify each expression. They both mean let's do the math and see what we get. So I'm going to do a couple with you, and then you're going to do a few on your own. Let's do number 6. 4 times negative 2 cubed to the 3rd power. So that means 4 times negative 2 times negative 2 times negative 2. We're going to expand our power. And if we follow order of operations, we get 4 times negative 2 is negative 8 times negative 2 times negative 2. Negative 8 times negative 2 is positive 16. And 16 times negative 2 leaves us with negative 32. Okay, so when you're first starting out, I really want you to slow down, show all the steps so that you can be careful with your negatives. Once you start doing a few of these, you're gonna notice some patterns. You're going to be able to do this a little bit quicker, but for now I want you to show all of your steps. All right, let's try number 9 together because it looks a little funny. We've got inside the parentheses, which means the base here is negative 4 times negative 2. And that quantity is being raised to the 3rd power. So we're going to follow order of operations. We're going to do what's inside the parentheses first. Negative 4 times negative 2 is positive 8. Now we have 8 cubed, or 8 to the 3rd power. 8 times 8 times 8. Okay, 8 times 8 is 64. And 64 times 8 is 512. Okay, so I want you to finish 7 and 8 on your own. Remember, follow order of operations and show all your steps. Take your time. All right, now it's time to try a few that are a little more interesting. Let's make it interesting here. We're going to evaluate these expressions, which means we're going to follow order of operations. We're going to go step by step. So let's do number 11 together. Negative 100 minus 2 times the quantity, 3 times 4 to the 2nd power. We're going to go inside parentheses first. 3 times 4 is 12. So now we have negative 100 minus 2 times 12 squared. We're going to do our exponent next. 12 squared is 144. Continue to follow order of operations. We're going to multiply 2 times 144 and get 288. And lastly, we're going to subtract. Now we have negative 100 minus 288. Remember, if you need to, you can ding-dong the problem. Negative 100 plus a negative 288, which leaves us with negative 388. Okay, let's do 12 together. Again, order of operations. Let's go inside those parentheses. Now in the parentheses we have addition and we have an exponent. Which one goes first? The exponent does. So we've got 3 squared, which is 9. And we're going to add and we get 12. Now we're going to multiply. 4 times 12 is 48. And then lastly we're going to subtract. 15 minus 48 leaves us with a negative 33. All right, and example number 13 is for you to try on your own. 25 minus 3 times the quantity 4 times 3 squared. Remember, you're always going to follow order of operations whenever you're evaluating an expression. All right, now let's look at some patterns. Let's look at this pattern here so we can learn some special things about the exponents of 1 and 0. So 5 to the 4th is 625. Remember, that's 5 times 5 times 5 times 5. 5 cubed is 125. 5 times 5 times 5. 5 squared is 25. 5 times 5. Oh, look, what's happening? What math is happening when we go from 5 to the 4th to 5 cubed? Yep, what we're doing here is we're dividing by 5. Notice we have one less factor of 5 each time, so we must be dividing by 5 to get rid of that factor. So each time we're dividing by 5, what's going to be next in our pattern? 5 to the 1st would be 25 divided by 5, or 5. Huh, interesting. Now we're going to continue the pattern. We're going to divide by 5 again. 5 divided by 5 is 1. Wow! So what have we learned here? Now this is going to work with any exponent and any base that we choose. Anything to the first power ends up being itself. 5 to the first power was 5. So anything to the first power is itself, or the base. Anything to the 0 power is going to be 1. How cool is that?